Hey guys, Mr. Riz here to wrap up the 224 section here with the third part, looking at distributed computing. So distributed computing is a computational model in which multiple servers are used to run a program. So distributed computing allows problems to be solved that could not have been solved on just a single computer because of either the processing time or the storage needed involved. So distributed computing allows for a much larger problem to be solved quicker than they could be just using a single computer. So some of the following examples of distributed solutions are below. So each solution comprises multiple servers that search millions of sources. So like large consumer sites like Amazon, there's not just one computer that's Amazon, or social media services that have just a huge volume of users, your Facebook, your Instagram, search engines like Google, large research databases and data processing solutions, or very large and complex computation. So like some universities have computers, like especially some of the math universities that do some complex things. I know there's always like computers out there that are calculating the digits of pi and just going through that. So let's look at just some of those here, just as an example, like looking at Amazon. You can see like the computer can send the results. It goes to Amazon server. The Amazon can then go to multiple different servers over here and get the results. And it distributes the load throughout the multiple different devices that are on it. And you get to see some pop-ups too. All right, part of it, we have to look at the scalability and the reliability. So distributed solutions are very powerful because they can take huge amounts of input, data, and requests and distribute them among a variety of machines in the system. So if the input load increases significantly, so if we get a lot of people asking for that more and more machines can be added to the distributed system. So which makes the system very scalable. It gets larger and it's easier to just make bigger and bigger. So you can see like before, if Amazon needed more, we got more users asking them, they could just pop up and add some more computers to this. And it can help work out the payload here where, the inputs can go to different payloads. You can see here's like a DNS server that distributes the work to different computers that are out there. So if a machine in a distributed system fails, it does not affect the overall system because the tasks that they were running on the machine can be picked up by another one. So you think of it almost like a team of people like trying to process or answer questions. If you had a bunch of people, working, just like at a checkout line at Kroger or something like that, you can have one person be the whole checkout line. But as more people come, you might want to have more checkout lines open so you can get more people through and through. Now, if John's out there working the checkout line and he just collapses and falls over and is dead, it doesn't mean the store just shuts down. It means the other lines get a little bit busier. The other lines pick up the load that they take care of when John's deceased, but it's all going to be better in the end. It will keep working. So avoiding this system failure is important, and distributing these solutions basically make it what's known as fault tolerant. So it can handle a fault. So at home distributed computing projects. So in some cases, some very large computing projects can run their distributed solution on thousands of personal computers owned by volunteers across the globe who've installed a special software on their system and donated their computers idle time in the project. So there's a bunch of them that are out there. You basically just say like, hey, you can use my computer during its idle time to help run some things. I know there's a couple ones that have been out there. I remember the first one that I was introduced was actually used the PlayStation 3, that it used its idle time, and it was kind of interesting to hook that up for. So in other words, anytime that they were not actively using their personal computer or personal device, the project will use the processor in that to process and run programs as part of the project. So an example of an at-home project is the STI at-home project by the University of California, Berkeley. So the goal of the project was to analyze radio signals in search of signs of extraterrestrial intelligence. One of the many projects stated as part of the worldwide STI effort. All right. More information can be found online if you look for this. So what other kind of information do you think could be benefit from it at home? So we can think about other different things that are out there. You can have people that just have like massive amount of data that needs to be processed and using different computers to do that. Um, you can kind of say some of these things too could be like going through and helping computers recognize like I guess artificial intelligence, looking scanning through emails and noticing how people respond to certain words or certain contexts can help build artificial intelligence to become more adaptive and more I guess, responsive to people, but you'd have to have a huge source of emails to kind of pick up on the little nuances of people's languages and notice that, certain things could be regional. So the way that somebody in Ohio answers would be different than somebody in Texas answers. And that would be something. So you can compare all those and you'd have to go through lots of different things and just compare and, scan and file and go through all those. So those are just a lot of different things that could be out there that you can go through. So what you guys are going to do for this project here is you guys are going to look up an at-home distributed computing project. And so it might just be as easy as highlighting that and doing a Google search and seeing some of the lists. Here we got a list on Wikipedia of distributed computing projects here. And some of them could be interesting here. And so you might want to just look on the research focus and see, what sounds something interesting to you. So you're going to find some of those. You're going to name the name it and goal of the project and name the organization behind it. Put the start and end date if it's, if it does have an end date. Total number of users and why is this project important? So we could go through and make this a jigsaw, but there's plenty of them on here that you can go through and see like maybe, let's try to find something that looks just all right. Dream Lab is doing some COVID-19 research here. I mean, it's sure it's processing. Oh yeah, protein folding. Oh yeah, just think about like a DNA, like how long that takes. Generalizing computer networks. There's the SETI home, which was like extraterrestrial, looking at RNA structure. So if you're in like biomed, you can kind of think about things like that. If you had to analyze the DNA of like so many thousands of different objects and then compare those, go through, and then there's even some more here. So this is a good one to go through. Um, Try to find one that, just kind of tickles your fancy. And what is this one here? Yeah, just give a brief description of that. So take some time, make sure you can explain what it is in the paragraph here, and you can kind of understand, a big distributed computing project that we, have been working on as a society. All right, guys, have a great time. Explore this. It's going to be great to kind of talk about and share the results. And I will see you guys next time. Have a good one.